Hello everyone, welcome back to SAT Math Question of the Day. Here's our question. It's a little hard to read, but we had to fit everything on the screen. Please try it, pause it, come back, and we will try to do it. Okay, here we go. A third degree polynomial p has factors x, x minus 1, and x minus 4. Which of the following could be the graph of the function? So this is graph of polynomial functions having to do with the nature of the roots and how what they call the multiplicity of the roots has to deal
Well, it's
with.
also about the nature of where the curve goes
Yeah.
when x is very large or its negative is very large.
Yes,
On
that's
the
true.
far
Right.
sides of the x-axis,
Right.
the behavior of the curve.
Right. So it has to do with the nature, how the roots cross the axis, and where the root and behavior as to where the roots grow at the end.
No. The word
Not
is
the
one.
roots. Not the roots.
It's about the roots, and two, it's about the behavior for large x.
Yeah, I made a mistake when I said end behavior where the roots go. Cross that out. Yes, it's the end behavior. What happens when x gets large in either direction, and the nature of the roots. Got it. So it looks like, what have we got? We've got roots at 4, 1, and 0. Okay, yeah, well, we know that, right? Okay, obviously we know that. Now,
Wait, why is 0 a root?
because the factors are x, x minus 1, and x minus 4.
How do you know that x is a factor?
Because it says a third degree has factors of x. So
Oh, brilliant.
Thank you, Seth. So
okay, thank you.
Up, and there are 3 different ways you can multiply this.
So it's really, they really made it a lot easier. They actually told you.
Yes. Okay. So let's do. Yeah. Okay. So this is a simple cross because it's on a multiplicity of 1. This is also a simple cross because it's got a multiplicity of 1. Oh wait. Oh, they don't tell us what the. Oh my God! They don't tell us what the multiplicities are.
But they tell you it's third degree.
They tell you the third degree, right? Good point. Good point. So the multiplicities.
So they gave you 3 different roots,
right?
And they told you that the degree is 3,
right?
Therefore, there are precisely 3 roots. They're all different.
Right.
So none of the roots have more than 1 multiplicity.
So we have to knock this one out because over here it does a little bounce on 0. See, it doesn't go through 0. Right?
It doesn't go through 0. It has a multiplicity of 2 with the 0.
Yeah, yes. So this would be x squared times whatever, times things with multiplicities of 1. So goodbye 3, goodbye 3, goodbye 3. So now it's either 1 or 2. So, those are the factors. And they both cross, don't they? They both have some, so it's between 1 and 2. Well, it's not, but it can't be. No, it can't be both because they have a different end behavior. They can't be both because they have a different end behavior, right? For x going large, it goes this way. And for x going large, it goes this way. So guess what? Oh, right. So it can't be this one. My God, we could do the problem without even doing it. Right? Because it can't be both.
I am silent.
Wait, maybe it can.
I will put something down silently. Ready?
Maybe it can be both.
I will put something down silently.
Yes, it can be both. It can be both. Sorry. It can be both because they say that these are the roots. So you could have plus 7x, x minus 1, x minus 4 is equal to 0, or you could have negative 8, x minus 1, x minus 4 equal to 0. They both have the same roots, and they each have n behavior. So the answer, in fact, is corrected. It is this one. It is this one.
Yes.
It is this one, yeah. I don't know what I would have done on the real test. I probably would have thought about it a little bit more before answering.
Yeah, but notice that that responses 1 and 2 are mirror images.
Yep.
they're reflections across the x-axis.
Right.
So they are a reflection. A simple reflection across the x-axis means that a point with a positive y coordinate on the top will correspond to a point with the negative of that y coordinate on the bottom with the same x.
Right.
So one of them has so this one, where it grows positively when x is large, this one behaves like positive x cubed for large x, and this one behaves the negative of that, minus x cubed for large, and in fact, absolute value of x.
Right. Well, no. Yeah, so yes. That's right. For yeah, right. Yeah. Yep. So then it's both, because the way the question is worded, a third degree polynomial has these factors. And yes, you could have a plus sign in front of these factors or a negative sign. You can have any number except 0 in front of these factors, and it would pass.
Okay. So remark, if they didn't say third degree, if they simply said polynomial,
yeah,
then any of the three would be possible.
Right, exactly. That's right. Absolutely, that's right. Because they didn't tell us. I'm sure I made a little thinking mistake at the beginning where I assumed these were. Well, no, I asked what are the multiplicities, and I said this was a 1 because I looked at this, and that was wrong. That was wrong, but it all worked out. Yeah. Right.
Yeah, let's say evaluated at 2. If you evaluated at 2, you get 2 times 1 times minus 2, right?
Yeah.
So you get minus 4, and it looks like it goes through minus 4. So, and here it goes through plus 4. So what they did was at the exact polynomial that they plotted was on the top plus, on the bottom minus, x times x minus 1 times x minus 4.
They had their coefficient be a 1 here.
Yeah, they exactly.
So this is a 1. This is a negative 1. And this doesn't apply. But this would be a plus. I don't know what would that be? The bottom one.
Yeah. The bottom one, if you multiply it by, it goes through what? Minus 4, and they multiply it by 2, minus 8. This goes through about minus 8 here. So this one, I think, is exactly x squared times x.
X minus 1.
Yeah. Doesn't do the undo. X squared times
x minus 1 times x.
X squared times x minus 1 times x minus 4.
Right. So in other words, the coefficient there is a 1.
Well, yeah.
Okay. So let's see how they do it. So we'll clear everything. We will do this. So we say it is 1 and 2. I'm sure they make a big point that it has to be a third degree polynomial. Okay.
Well, let's see.
Check.
Let's see how they explain it.
Now see how we answer the question. Now we can go bigger font. No, we go bigger font. Sorry. Bigger font. There we go. Now it's easier to read. Okay, since P is a third degree polynomial, that's right. That was really, really important. It follows that it has the factors where these, what to call multiplicities, these things. Why, come on. These things, oh, Man, God. Okay, these things are to the first power, to the first power, to the first power. And why did those disappear? I have no idea. First power, first power, first power. Okay, recall that for real number x minus k is a factor of a polynomial. Okay, so that it intersects there based on this. Those are the zeros. We knew that. Additionally, each factor occurs only once. So it must cross the x-axis, because when you have a multiplicity of 1, which is so weird here because it disappears. It's so strange, right? Okay. 1. Who would think there's a zoom feature where you can write something and then it disappears? But that's what it is. It crosses at those points once because the multiplicity is 1, so it crosses. It doesn't bounce. Of the 3, 1 and 2 are the hit criteria. That's right. Those are the only ones that hit that criteria. So the answer is 1 and 2.
What would it look like if the polynomial were x cubed times x minus 1 times x minus 4?
Hold on. Let me first clear all these drawings. What is that?
X cubed times x minus 1 times x minus 4.
It would look very similar, except it would have a little jiggle here. It would come up and have a little jiggle and then go like that. There would be a little jiggle here as opposed to a cross. Like that would be a cross. That would be the x cubed.
Okay. Yeah, let me draw the little jiggle a little bit. Let me draw the little jiggle a little bit more realistically.
Oh, good. I'm glad they said this. That they're rejecting number 3 because number 3 would suggest a double root. Number 3, I mean, in answer part 3, what they're talking about is a double root. It would come in x squared. See, x squared, x minus 1, x minus 4. If that's what they're talking about here, they're talking about this situation. In that situation, the thing comes in and bounces off the x-axis.
Yeah, so I'll say we talk about, draw this a little better. What goes up? Look at this. It's tangent. I'm sorry. It's very wrong. It's not square. Shapes.
Oh, you're doing the jiggle, right? You're doing the x cubed jiggle.
Yes, I wouldn't. Let me draw and there it is. Those are the axes, and here's the curve. Comes up. It's tangent, and then it continues being tangent. It goes up like that.
Right. Oh, I see. I see. But
it's not a little jiggle. It's it flattens out, and then it unflattens at the same rate.
I see. So in other words, it
tangent
comes up.
It has a horizontal tangent, but the curve crosses the tangent.
Got it. So it just touches. Right. That's a good way of thinking about it. I would just do a jiggle, but you're right. This is wrong. It's not a jiggle. It's a tangent. You're right. That's more precise. Right. Comes up. It's tangent to it like that, and then it's tangent to it again like that. That's a good way of thinking about it.
Yeah.
Okay, that leads into Seth's educational background. He has a PhD in math from MIT and has been teaching computer science for many years. He's now professor emeritus at SUNY Albany. I have a PhD in mechanical engineering, so I just say jiggle as opposed to tangent. More just get it done, practical approach. We try to offer different approaches to doing the SAT math questions. We're very cognizant that if you do these questions on a test in school, you do a slightly different approach than the SAT, because on the SAT you have to do the problems a lot faster. Okay, and then in terms of approach studying for the math SAT, we suggest going to Khan Academy. They offer hundreds, maybe 600 or 700 math questions that are partnered with the College Board. So they're sanctioned by the College Board, and they tell you basically what's on the test. And practicing, you get to practice exactly what's on the test. They have the digital and non-digital classes, depending on which one you're going to take. And I think that is it. Please dislike our video, give us comments. We're more than welcome, encouraged, so we get some feedback. And if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com. I think that's it for today, right?
That's it. Yeah, that's it.
Okay. Take care, everyone.